class, we are going to see about physical quantities and measurement. So in this lesson, you will be learning about measuring the area of irregular shapes, measuring the volume of liquids. You will learn what is density and relative density, and we will also learn about what is mass and weight. We will compare both the terms. We will compare both the physical terms called mass and weight. So shall we move to the first topic? Yes, our first topic is measuring the area of irregular shapes. So what are the shapes which you are seeing here? One is circle, one is triangle, one is rectangle. So when I am asking you to find the area of such regular shapes, you can easily find out, right? How? You can use those standard formulas for each regular shapes. You can apply the parameters which have been given to you, or you can easily measure the parameters in the regular shapes and find out the answers, right? But when I suddenly give you a leaf and asking you to find out the area of such leaf, will you be able to do that? No, we haven't learned that here, right? So, how will you measure the area of such irregular shapes? Yes, we are going to learn that. I'm going to take this irregular shape as an example. Okay, so to find out the area easily, we need something like graph paper. So you can see that it is something similar to graph paper. Each square is having area of 1 centimeter square. When you see your graph paper also, you can notice that each bold squares present are actually having the area of 1 centimeter square. But in your graph paper, there will also be further small squares of area 1 square millimeter. Here I don't have such smaller squares, only I'm having the squares of area 1 square centimeter. So the first step we have to do is we have to draw the outline of our irregular shape. So now we know that the area of each square is 1 centimeter square. So if you can count the total number of squares present within the outline, you can easily find out the area of irregular shapes by your counting itself. For example, so let's say there are some 15 squares present within this. So each area is actually 1 centimeter square. So 15 into 1, it's actually 15 centimeter square. So by counting itself, we can easily and approximately, it's not accurate, we are just counting and finding, right? So it's only approximate measure of the area. So now, as I have said, I'm going to consider the full squares within the outline. Okay, the full squares within the outline. I'm going to color the full squares with yellow color. So yes, all these squares are actually full squares, and we'll also count that. Okay, and as I said earlier, we are also going to consider the half squares are more than half square present within the outline. Half squares are more than half square. Actually, we are going to consider them as approximately a full square. Okay, definitely more than half of the region has been present within the outline. I'm going to mark them with the green dot. So here more than half square. Yes, here also more than half. So I'm going to continue the process. Clearly watch all those squares which are present half of or more than half have been marked by the green dot. Yes, I have done the first step, that is marking. Now we are going to count. So how many full squares are there? You quickly count. And how many half squares and more than half squares are there? Yes, you are going to count. And so you can see number of full squares is 10. I think you have counted. And number of half or more than half squares is, yes, 15. It's 15. So total number of squares present is 10 plus 15, 25. As I said earlier, area of each large square is 1 centimeter square. When you multiply the total number of squares and the area of each large square, you can actually find the area of irregular region. That's what I have done here on the board. So 25 into 1, because this is the total number of squares I have considered, into 1. 1 is the area of each large square, and yes, 25 centimeter square. So this is the approximate measure uh, of the area of this irregular shape. Definitely this is not accurate one, because on seeing itself, by just counting we are doing the measure. Definitely it's not the accurate one, but it's the approximate one, right? So now I think when I'm giving you a leaf, you can just find the approximate area of the leaf, right? Let us move on to the next topic of this lesson, that is measuring the volume of liquids and irregular solids. First of all, we have to recap ourselves about how can we find the volume of normal regular solids. So what is volume of an object? It is actually the space occupied by the object. In case of this ball, the air is presenting inside, right? So that air space is occupied by this object. So that is the volume of this object. Similarly, we have so many formulas for many regular objects. We have already learnt that in case of cube, it's B is equal to cube of the sides. In case of right circular cylinder, it is actually pi r square h. You have to um, you have to multiply the area of the circle in the bottom, and the height of the cylinder, right? So this is the formulas we have already learned. How can we put the unit of the volume? The unit of the volume is actually represented by the cube of the unit of the length. That means if you are measuring the length to find the volume in centimeters, you should represent the unit of the volume as centimeter cube. If you are measuring the length in meters, it should be represented in meter cube. You should be very careful in this while doing problems. When you're measuring the length in centimeters, you should not represent the unit of volume in meters. Okay, it should go like this, not like this. So for the unit centimeter, it should be centimeter cube. Meter, it should be meter cube. Okay. So let us move on to our main topic, that is measuring the volume of liquids. How can we do that? In normal life, we use containers with fixed capacity. You may have seen such containers in your home itself. Your mother would have used such containers for measuring milk or something. While buying itself, the capacity of the containers or the vessels would have been specified. Okay, we can use such kind of containers, but while using this kind of containers, it is not possible for us to measure some amount of volume. Like you cannot measure 20 milliliter in this, right? Because there is no provision for you to measure very small amount of volume. For that, we are using measuring cup and measuring cylinder. You may have seen this kind of measuring cups and measuring cylinder when you have visited the lab, physics or chemistry lab, right? So, as I mentioned, using this kind of measuring cup and measuring cylinder, it is possible for us to measure even small quantity or small volume of liquid, right? So you can see the graduations like 20, 40, 60, 80, 100. When I ask you to get me the 60 milliliter of water, you can easily pour the water into this beaker and give me the 60 milliliter of water using this graduation by referring to the graduation. So graduation, it helps us to attain the greater accuracy in terms of measuring the volume, right? We will learn how to measure the volume of irregular solids by water displacement method. What is this? Yes, this is stone. This is one of the irregular solids, and I'm going to use a measuring cup with graduations to know the volume of this irregular solid. How can we do that? I mentioned water displacement method. Let us let us see what is it. I have filled this measuring cup with 600 milliliter of water. So initial volume of water is 600 milliliter. Now I am going to drop this stone into this measuring cup. When you drop the stones or any material into the water or any liquid, what will happen? Actually, the water level will rise. So here also, the water level has been raised from 600 milliliter to 800 milliliter. We can measure using this graduation, right? So initial volume is 600 milliliter and the final volume is 800 millimeter. And this is the volume of liquid displaced, right? So what is the initial volume? It's 600 milliliter. What is the final volume? It's 800 milliliter. And volume of liquid displaced is 200 milliliter. Normally what I have done is 800 milliliter minus 600 milliliter. I have got 200 milliliter. And this is the volume of the stone itself. Since we have put the stone into the water, the stone makes the same amount of the volume of water to be raised by it. So the volume of liquid displaced, which is actually equal to the volume of object itself, right? So the volume of stone, we have found it as 200 milliliter in this case. We will now discuss the questions on measuring irregular areas and measuring volume of liquids and irregular solids. Define volume and write its SI unit. Volume of an object is defined as the space occupied by the object. SI unit of volume is meter cube. How will you calculate the volume of irregular solids? When a solid is immersed in water, it makes space for itself by displacing water. Obviously, the volume of water displaced by a solid is equal to the volume of the solid. This fact is used to measure the volume of irregular solids. Let us see how by trying to find the volume of a stone. You will need a measuring cylinder, a small stone which can move easily inside the cylinder, some string and water. Take some water in the cylinder as shown in the figure 2.14a. Read the level of a stone on the scale marked on the wall of the cylinder. Then tie the string around the stone and lower it gently into the water till it is completely submerged as in figure 2.14b. Read the level of water again. The difference between the two readings give the volume of the stone. For the case shown in figure 2.14, the initial reading is 20 ml, that is 20 milliliter, and the final reading is 24 milliliter. The volume of the stone is equal to 24 milliliter minus 20 milliliter is equal to 4 milliliter. So we found the volume of a stone as 4 milliliter. We will move on to our next question. How will you calculate the area of irregular shapes? To find the area of the figure with a regular geometric shape like square, rectangle, or triangle, we need to make only one or two measurements. Then we can obtain the area using standard formulae. However, to find the area of an irregular shape, we have to use a graph paper. A graph paper has a number of parallel lines, both horizontal and vertical. The thicker lines are 1 centimeter apart, while the thinner lines are 1 millimeter apart. Thus, the entire paper is divided into small squares of area 1 millimeter square each, and large squares of area 1 centimeter square each. Place a piece of paper or cardboard with an irregular shape on a graph paper and draw its outline. To find the area enclosed by the outline, count the number of squares inside it. You will find that some squares lie partially inside the outline. Count a square only if half or more of it lies inside the outline. The total number of squares multiplied by the area of each square gives the area inside the outline. For the shape in figure 2.10, we have the following. Number of complete square within the outline is 10. Number of squares with half or more within the outline is equal to 7. The total number of squares is equal to 17. The area of each large square is equal to 1 centimeter square. The area of irregular shape is equal to total number of squares into area of each large square. That's why we have put it like 17 into 1 centimeter square is equal to 17 centimeter square. So we have found the area of irregular shape as 17 centimeter square. Assignment for this topic Assignment for these topics are: list out the 5 different containers in your home and find out its capacity. Calculate the volume of water you drink in one day. Third question is: collect 3 different kinds of leaves and find its area. Third question is Fourth question is: the volume of water in a measuring cylinder is 55 milliliter. When a stone tied to a string is immersed in the water level rises to 83 milliliter. Find the volume of the stone.